Okay, good morning class. Sorry of the delay in start. So today we're looking at our last section on, our last lesson on trig graphs, no? Before we go into revision for the final exam. Okay, so at this point, let's just check what we have. You're on 12C?
Yes.
So worksheet 12C. It says sketch the graphs on the same set of axes. So we need an axis of symmetry. Still one here. What was the interval on that graph? Negative 180 to 180. Did I draw a what's the name I get before? I should have an axis. Otherwise I'm going to draw one now. I think the tan graph was in that period, does it? Again, I would need somebody to read. Nope, not what I'm looking for. What is the tan graph that I asked you to draw there? 210. So that's not going to work for us because that is the tan of x graph, so I'll delete that. I just deleted the graph now. Let me see if it's still in the bin. Restore. That is that one graph we just looked at now. So I must remove the graph. Alright, let's see. So we needed to draw the 2 tan x graph. Let's put it here so that you know where it's coming from. So we're drawing the 2 tan x graph. So tan of 0 is of course 0. Tan of 45 is 2, correct? Tan of 90 is asymptote, undefined. Tan of 135 is minus 2. And 180 is 0. Don't go past this 180 point here. Okay? Negative 90 is again an asymptote. And negative 45 is going to negative 2. At least one of the points we write in there. And then 180 and 0, 135 and 2. And this is that given G or F or what? F or X. So I can just put F, I don't need to put the equation. Okay. What's the equation of G of X? Cos of X? Cos of X plus 1. So it's the cos of X graph, the basic cos graph, plus 1. So that graph is going to move 1 unit up. So this point here, so then I'll go to 2 of course. This point of 90 goes to 1. This point of negative 1 go to 0. So there's that part of the graph. course, the graph repeats itself on the side as well. And that is the g of x graph. Okay, so I just need the equations here, the questions that follow. So g of x is equal to cos x plus 1, and f of x equals 2 tan x. No? Right. What's the first question pertaining this graph? What's the amplitude of g? So the amplitude is from the neutral to the maximum, to the middle to the maximum. And what's the amplitude there? What's that distance? From the middle to the maximum. 1, yes. As I explained to you before, you could have looked in front of that. That is also your amplitude. Whatever value is in front of the sign and the cos there, the constant or the absolute value of that, the positive constant or the absolute value, which we need to say it must be positive. The amplitude is always measured as a positive value. No? Whatever value is in front of sine and cos then as a coefficient is your amplitude. Okay. So the amplitude is 1. Next, the period of the f of x graph. The period of the f of x graph is 180. Okay. Why? Because at the time taken to complete one full cycle is 180 degrees. Next. Sorry? G is decreasing. So which question is that? C. 1.4. G is decreasing. So if you're looking at the g of x graph here, is this part of the graph increasing or decreasing? It's increasing. As x increases, as we're reading from left to right, we always read in that order, the graph is increasing. But here you see the graph is decreasing. So it's increasing, so it's decreasing from 0 till 180. So x is greater than 0 but less than 180. Do you think I'm going to put an equal sign under the 0 there? Under that inequality? Why? No. Yes. Why? Because it's turning there. And the turning point is neither increasing nor decreasing. At 180, do you think I'm going to put the equal sign here? No. Why? Because another turning point. Remember, the graph is going to do that on the side. So no in both cases. Alright. Next question, 1.5. G of x is less than or equal to 0. So in other words, it is where the g of x graph is below the x-axis, below this line here. Where the g of x graph, below that line means negative. Also, so is there any part of the graph below that line? No. Okay? So we won't find a part where g of x is less than 0. However, there's an equal to as well. Where g of x equal to 0? It's equal to 0 at negative 180 and 180. So this answer here is x is equal to negative 180 or x is equal to 180. Okay, or you could have written it as x is equal to plus minus 1. It's the same thing. Okay? You guys understand? Next. So it's question 2. Sketch on a different set of axes the graphs of tan of x plus 1. There's 3 graphs we need to sketch. In number 2.4, it says what is the amplitude of the function in 2.2. Look at them, what's the amplitude in the function in 2 years? You see the number in front of cos is negative 2. So if we take the absolute value or the positive value, it will be 2. Give the period of the function in 2.3. 180. Okay, so I'm not going to answer those 2 questions. So I can just draw those two graphs quickly, or three graphs on. So the first graph is from, I'm going to use the same axis here. What's the first equation? Y equals tan x plus 1. It's actually the tan graph shifted 1 unit up. Okay, so it's going from negative 180 to 180. So this axis is perfect for what they want you to do here. Okay? So the tan, this of course 90, remains the asymptote. That's x equal to minus 90 and x equal to 90 here. So normally starts at 0, but it starts now at 1, since the graph is 1 unit up. 45 is normally 1, but it's going out to 2. That's part of the graph there, so I put 45 and 2 there. There's 45 and negative 1 goes to 45 and 0. There's 180 and 1, 135. That's an end point, so normally I put that in as well. This is normally 180 and 0, become negative 180 and 1. Also an end point there. Negative 135 and 1 goes to 135 and 2. So there's the graph. Okay. Don't forget to insert your endpoints. Okay. The mark educated. Any issues here? No? Let's look at the next graph. See the space below here? No. So let's take this off now. What's the second equation? Y equals 2 cos x minus 1. So it's the cos x graph inverted, enlarged or split by a factor of 2. So it's the cos graph is going to do that at 2 and minus 2. Then what happens to the graph? It then moves 1 unit down. Okay. But what's the interval of this graph? X is greater than or equal to? Negative 90, but is it equal to? 180. So this part of the graph is correct, but that's where they want to stop. So this part of the graph I'm not going to draw it. If you draw it in the exam, normally you won't even draw that part of the graph. You guys understand? Okay. So you take that point into account. So it's going to move 1 unit. And remember that is normally 180. No? That is 360. So that moves 1 unit down. So it goes to minus 1. This here, which is 90 and minus 2, becomes 90 and minus 3. It's a turning point, so I put it in there. This point is 180 and 0 becomes 180 and minus 1. That's an input. Okay? So there, that part of the graph. Okay? Then, of course, the graph does that on the other side as well. Not so. So, this point here is normally 90 minus 90, and in this case it's going to be 2, but move 1 unit down, so it's 90 and 1. You see that? So, the graph is actually cut like it. Okay? You guys understand? Again, if you had used the 0, 90, 180 and minus 90, you would have gotten the points anyway. Yeah? So you don't need to, but like I said, the more you draw the graph, the easier it will become to plot the points. We'll plot the graph without the calculator. Okay. And what's the last one? Negative 2 tenths. And this is from where x is greater than or equal to? negative 90 but less than or equal to 90. Which means to say I'm going to only draw it from there to there. Well, that is on your asymptotes already, not so. So then, here's that. And that part of the graph as well. Okay. Now the negative tan graph will reflect the graph in the x-axis. So 0 and 0 remain 0 and 0. 45 will become now minus 2. That point I put in, 45 and minus 2. The graph is going to come close, doesn't touch, goes through there. The negative 45 will now go through 2. And there's that graph. Okay? Let's carry on. Question 3. Determine the equation of the following. So where do we start? Sorry? We substitute one of the points. Not some, there are 2 unknowns, so you need 2 points at least. Okay? From this we can see this graph is going to be y is equal to 1 sine x minus 1. Yeah, I think it would be that. Okay, but let's make sure. So what we do is we substitute 90 and why could I say 0 and minus 1? Not so. We substitute 0 and minus 1. It's an x and a y. Not so. So you're going to get minus 1 is equal to a sine 0 plus q. What is sine of 0? 0. So 0 times a is 0, so q is equal to minus 1. So the equation now reads y is equal to a sine x minus 1. You see here I don't say equation 1 and equation 2. Why? Because I just have one unknown there. Then I sub it back into the formula. Okay, so this time becomes the formula. Now we substitute 90 and 0 now. This is again x and a y. So it's going to be 0 is equal to a sine 90 minus 1. What is sine of 90? 1. So minus a is equal to minus 1. So a is equal to 1. So the equation y is equal to 1 sine x minus 1. Okay. If that was f of x, I would have just put in here and f of x. Number 3. Oh, I just worked it out without even reading the question. Determine the equation, right? But now there's only an a and a q there. I see I got a b as well. Where's the b? Sorry? There's no b, okay? So let's look at the questions pertaining this. Calculate the value, so that is 3.1. Okay, we're jumping the gun there. I thought they were just asking you to determine the equation. Or probably number 4 is a b. Okay, give the range of g. People, what is the range? Range all possible y values. So where does this graph start existing at? Negative 2, and it goes all the way to 0. So that's the range of the graph. So in other words, y must be greater than negative 2, but they said 0. Does the graph exist at negative 2? Yes. Does it exist at 0? Yes. It must be equal as well. Okay. The next question says, for which values of x? The values of x will g of x minus f of x. Now f of x minus g of x be equal to 2. Okay. For this graph, for this question, we need to know. We need to have an equation for g of x and an equation for f of x. Not so. Is there an equation for f and g here? No. So I can't answer the question. Okay. But just look at the question. Let's see where else was it 2 graphs, f and g. Yeah. Okay. Let's say that question belonged to this one. Okay. You guys okay with that, no? This was not part of it, but I'm going to answer it here. Where's f of x minus g of x equal to 2? That means to say that the distance between the two graphs is 2. Or when I subtract the two y values at a certain x value, you'll get a distance of 2. So if you look at f is your parabola, your what's the name graph here. Can you see here? Let's say this from there, this length is 2. No? Right. I hope it's going to work for what I'm showing you. There's not 2. Where do you see that you have 2 here? Can you see? That would be 2, but the distance between the x, the f and g is not 2. It's less than 2. Can you see that? Somewhere along here it's more than 2. Can you see? Or 2, somewhere there. That's not going to work for us. Can you see that distance is 2? But what do you notice? What is up top here? The g. Because here, your g value is 2 and your f value is 0. So here would have been 0 minus 2. That is minus 2. So that is not what they're looking for. Can you see that? So that's not going to work here. The f must be on top. Can you see it? Somewhere there again is going to be 2. And that's the case. Okay. So if I was going to set this paper, I would have asked with g of x minus f of x equal to 2. That distance be 2. And what is the answer? It's where x is equal to 0. Is that the case? Can you see that? You see there's another graph where there are 2 here. There's a f and there's a f and a g. Can you see here? So if you look here, let's say where's f of x minus g of x equal to 2. What's the distance between the two values there? Between f and g? 0. There's no distance there. Why? Because that's a point of intersection. Not so. Let's look at 90. What is that distance? That distance is 2. Can you see? What is f on top of g? Yes. So what is your answer here? X is equal to 90. Is where that is the case. What's the distance between 180? Remember this is 180 minus 1. Not so. So what is this distance? 1. From there to there is 1. From there to there is 1. So that distance is also 2. So x equal to 180. What's the distance there? No distance. There's a distance there? No distance. Can you see? But to answer this question, where is f of x minus g of x equal to 2? Well, the distance between the two graphs 2. It's 2 at x equal to 90 and x equal to 180. Let's see, is another case where we have two graphs. Yeah, we can also have two graphs. No? Where is the ever distance of 2? Between two graphs, there is a distance of 2. So x equal to 90. Can you see that? Provided the purple graph is on top of the turquoise graph. You guys see that? You get the idea? We will do more of this when we do past papers. Okay. That's it. That basically brings us to the end of your grade 10 syllabus. Alright, so we're going to choose a paper now. I'm going to stop the video at this point. We're going to choose a paper and we will do the paper from start to end. Okay. I have recorded a couple of papers, Mrs. Stop this. I have recorded a couple of